Hello and welcome to another tech tip by VMNerd. Our tech topic for today is how to set up encrypted DNS for external name resolution using pFSense. Our objectives are to create a visual build diagram of our demo infrastructure, set up and configure an Ubuntu Linux box that will route traffic from our pFSense firewall to the internet. This will allow us to see the traffic leaving our pFSense firewall. Install and configure any required tools to perform our testing. Perform real-time packet captures before we enable DNS with TLS. Enable DNS with TLS within pFSense. Perform real-time packet captures after enabling DNS with TLS. Set up internal-only DNS records for our last objective, which will be to force all LAN-based DNS through pFSense using network address translation. And with that, let's get started. Okay, so let's go ahead and start with our diagram of our demo infrastructure. I had pre-constructed this diagram to ease the pain of watching me construct it manually. Okay, so we'll go ahead and bring this up. The first thing we got is our internet provider. We have an internet IP, routable IP address of 192.240.123.35. This is our WAN or outside interface to our demo infrastructure. From there, we have an inside interface or LAN interface of 192.168.31.254. It's an RFC 1918 address, and it's not routable on the internet. From there, our router Linux box that we're going to put together will have an outside interface of 192.168.31.252, and this is basically the router side that's closest to the ISP. From there, we have an inside interface of 192.168.32.254, and that's our ETH1 interface on there, and that's going to connect to our pFSense firewall. So our pFSense firewall has a WAN and a LAN interface. The WAN interface on the pFSense firewall will be 192.168.32.250, and the LAN or inside interface will be 192.168.10.254. And from there, we have a management machine, which is what we're looking at this diagram on. It'll have an Ethernet address of 192.168.10.100 or some variation of that because it is dynamically assigned. Now, when we go to make our DNS request, so the DNS request will start out at our management machine here. It will get to the pFSense box. The pFSense box will basically intercept the communication and pass on behalf of the management box. And the reason why is we're running network address translation, which takes the 192.168.10 address, encapsulates it in this 32.250 address, and it asks all the questions on behalf of the clients behind in this 192.168.10 network area. So what we plan to do here is at the router layer, we plan to install Wireshark so we can do a packet capture and we can see that communication. And we're specifically looking for DNS. We want to make sure that we can see what unencrypted DNS looks like, and so you can see what your internet provider, as well as anybody who is intercepting your traffic, what they can see. Okay, and then we're going to go ahead and ratchet it down and encrypt our DNS traffic. And from there, those ports will actually transition over to port 853. UDP and TCP is both used in general, but I find that most of the packets are in TCP because they're more reliable. There's a lot of error correction and all that other good stuff that's going on. Okay, so let's go ahead and get constructing. First thing we need to do is we need to go ahead and start connecting with our Unix box. So 32.254. Okay, so we have VMNerd. Okay, so we went ahead and constructed this out. Something doesn't seem right, so let's see if we can do yahoo.com. Yep, we can. Perfect. Okay, so the first thing we need to do is elevate our privileges. Okay, so I'm going to go ahead and do an apt update. Yep, and basically this, in theory, should allow us to synchronize the cache that we have on our box here. Okay, so we'll go ahead and do an apt upgrade. Should have put the /y, it would have made this less painful. Okay, so let's go ahead and install, what is it, TShark, and we have to install libcap to bin, and I'm going to go ahead and put a -y there, so that way we don't have to see that painful, are you sure you want to do this, because we know we do. This is fun stuff. Okay, should this be run by non-super users? The answer is yes. Otherwise, we're going to get a painful, your root can't do this because you're ultra powerful. Bunch of nonsense. I get it, but come on, root should be able to do everything a user can with interest. Okay, so the first thing we need to do is we will do user mod a-g Wireshark and VMNerd. Perfect. Okay, chgrp, and we got to do a little bit of cleanup here because this is awesome and it doesn't always install correctly. User. I appreciate all the work people do, you know, with all these softwares, but it's not always perfect, even if we want them to be. Okay. And this should be the end of this, hopefully. And basically these commands I have to run just to allow non-root users the ability to perform packet captures. There's more to just doing a packet capture, so you run multiple applications at the same time. Okay. Alright, so the next thing, since we did all that, let's go ahead and just do a really quick test. So we'll exit out as root, we'll run, what is it, TShark. What is it? Cisco remote. Oh, that's great. Oh, that's right. I got to relog back in. We'll do that in a minute. We'll come back to that. All right. So the next thing we need to do is go ahead and enable routing on the interfaces here. So echo 1 slack proc sysnet IPv4 IP underscore forward. Spell that right, forward. Yep. Okay. And let's see. /sysctl conf. There it is. Where was it at? There it is. So just uncomment this out. Net IPv4, yep. Okay, so just for fun, let's go ahead and we're going to just do a quick reboot. We want to make sure that this is going to survive. Okay. What is it? 192.168.254-T should be up pretty soon. Okay, so it looks like it's back. Restart. And while we're in here, we'll go ahead and do a trial run here. So we'll do TShark. And that looks good. Okay. So we can see some activity here already. Okay. All right. So the next thing we need to do is let's go ahead and do some of our initial packet captures. Okay, so just based on how things are configured and all that stuff, let's go ahead and do some basic packet capture. servers. Okay. And then from there, we're going to go ahead and do some NS lookups, and we're going to see all this wonderful activity happening. Okay, so let's start by doing that. So we'll do a TShark dash. Actually, let's see what interfaces we have. So what we're going to do is we're going to see from ETH1, or ETH0, excuse me. So it's coming into ETH1 and then out ETH0. We want to see it. I guess we can look at it from either point of view. We can look at it from here, I guess. All right, let's do that. So TShark, TSHRK dash, what is it? It's 33. Host 192.168.32.250. And port 53. Okay. And I think, yeah, we can go. Let's go ahead and grep on this as well. And we'll look for, because there's going to be a lot of stuff coming out of here. We'll do example.com. Yeah, sounds good. Okay. All right, so now we're doing a packet capture. We're going to see what our internet provider sees. So let's go ahead and run a quick CMD. We'll do an NS lookup. And we will do example.com. Interesting. Let's try www. Oh. Okay, there we go. All right, so if you see right here, you can actually see any and all IP addresses that come through. So if you see where I started out, we did the grep just so that way we didn't see a bunch of noise. But if you look right here, you can actually see it. This is me making attempts to, I guess it didn't append the period at the end there. Probably a configuration issue that I have to deal with, but normally that's not the case. So, but as you can tell, you can see all this data, right? So you see that I'm requesting this and I'm looking for it here. Okay, and then it spits back a bunch of stuff. The bottom line is you can see it. You can see the request. That means your internet provider or anybody else for that matter who's eavesdropping on your network can see this. And that's what we're here to try to stop. Okay, so let's go ahead and we'll just minus this out. And let's go ahead and get into our pFSense box. Okay, so admin. All right, so this should be pretty straightforward. Let's go to DNS, what is it? I think it's under, yeah, so DNS Resolver. Start by going there. We're going to go ahead and enable the service. This will allow our DNS service to go ahead and respond to the local clients. Go ahead and use our SSL certificate. And then right here, this is where we specify the port, the network interface here. So this is going to be all interfaces that it's going to listen on. So we want it to listen on at a minimum the LAN, localhost. We really don't use IPv6, so it doesn't really matter. And then the outgoing interface always going to be the WAN. Okay, and we'll add localhost as well. Okay, so DNSSEC support. And in this case here, we're going to enable it in forwarding mode. Okay, and this is the real magic button here. This is where we're going to enable it. So based on this information, we're going to be forwarding it off to Google servers and things like that. And that should just about do it. Now, if you are using pFSense as your DHCP server, this is a great thing to add, especially if you want your internal clients to be able to resolve one another. So we could turn it on. I'm not sure if I have DHCP on, so go ahead and do a save. All right, we'll apply. Hopefully it doesn't blow chunks. Come on, demo gods. There we go. Alright, so we'll go here to the setup section and we'll look here. So Google does support the TLS, DNS over TLS, so we'll go ahead and add, like, what is it, Quad 9 is another one that does it. So we can add that, and that should be good enough. Cloudflare, I think they're 1.1.1, I believe. Or is it 4? I don't know. We'll deal with that later. But anyways, so Quad 9 is another organization that does this as well. So let's go ahead and do a save. Okay, so here's what we're going to do. On our packet capture, because we can't really see the traffic like before. So if I say, okay, I want to grep on example.com or something like that, that's not going to work anymore because I don't know what the request is going to look like. So I'm going to take off the grep component. Okay, and I'm going to add a little bit more to this because now we have to also look up for the new port. So we talked about port 53 as being one, and the other port is 853. So let's go ahead and add another one of these statements in here, 192.168.32.0 and port 853. Okay, looks good. We'll add that to close it out. And let's go ahead and do our lookup. So I'm going to do msn.com. And if you see right over here the difference, so when I went to do msn.com, I no longer see msn.com. So what I see is I see a bunch of TLS. So at this point, I mean, basically our DNS requests, they're no longer visible to anybody who is eavesdropping on your traffic. And you can see I did get results back. I got 0.0, which is not interesting. Let's go ahead and add the dot. Let's do that again. All right, so there. Now we got a real IP, 1382.28.61, and we have the same thing. So we still have the TLS traffic going on. Your DNS traffic is encrypted. The only thing you see is the IP, the source IP asking for it, and to what service or provider or wherever it is it's going, where it's going. That's all you see. And then you see all the response encrypted, so that way nobody can just, I guess, snoop on your traffic. So with that being said, this is exactly what we're looking to do. Now, the next thing we need to do on top of this is that, you know, anybody willy-nilly can bypass our firewalls. So let's go ahead and turn this back on. And instead, what I'm going to do is I'm going to switch my DNS somewhere else. So let's go straight to Google. Okay. So, and you're going to see this with your smart devices, right? Your, you know, your Chromecasts or anything like that. So if I type in yahoo.com, going straight to Resolver, in theory, I should be able to see that. Oops, I'm going to add the period at the end there. But I'll be able to see that. So this kind of hurts. I mean, if you're trying to protect against that kind of eavesdropping or things like that, this traffic can still be seen. So what we need to do now is we need to take all your traffic there and force it through your local resolver that's hanging off of pFSense. And the way we're going to do that is we're going to do that through a NAT translation. So let's go ahead and close this out. Go ahead and clean this up just so that way it's nice and clean for us when we go to do a capture after the fact. Okay, so let's go ahead and go into our DNS Resolver, or sorry, let's go to our NAT translations, and what we're going to do is we're going to do a port forward. Okay, so instead of interface WAN, we're going to do LAN, and the destination we're going to put, as long as it's not talking to the LAN and it's coming in over DNS, and this would be TCP and UDP, we're going to redirect it to 127.0.0.1, and that's the loopback adapter, if you will, on the pFSense box. And we're going to redirect it to the local DNS, so that way whenever you go to make a request, your request will go through and it'll see that, hey, it's not allowed. We're going to redirect it to the local resolver. So let's go ahead and check the firewall rules just to make sure that that is the priority. So when you have a default rule that says basically go anywhere, you need to make sure that this rule is in front of that rule. So that way this one here takes priority. Okay, it's just something you have to do, a little bit of maintenance, because this rule is always usually there by default. Some people may have things a little bit more craftier, so you're going to want this rule up a little higher up. Okay, and just to prove that we are connecting locally, I want to go ahead and add a local entry of our own. Okay, so we're going to do a host override, not a domain, just because it's simpler. So we'll do www, I think we did msn.com earlier, so we'll use msn.com, and we'll just point it to our local router, if you will, 168.10.254. Actually, let's pick some other host. We'll do blue.com. Okay. And this is just so that way you can see that when I type this, it's going to force it through, but you'll also see it when we do the packet captures. Okay, so go ahead and do that. And we have that entry. So let's go ahead and go back to our packet capture. Okay, we'll turn it on. And let's go ahead and type in, actually let's exit out. Okay, we'll do our lookup. We're going to type in www.blue.com dot, and you should see this will be encrypted because we're going to our pFSense box. Okay. Should see more than that, hopefully. Oh, that's right, because it's not going anywhere. It's using the local resolver. So let's just try blue by itself, right? So we should see that in our packet capture, and it should be fully encrypted and all that wonderful stuff. Okay, so we did get a result, and if you notice, I did get the 192.168.10. Now, this is where it gets interesting, right? So before we switched our server to Google servers to go directly, and like I said, your smart devices are the ones that are actually going to do this because they want a phone home and they want those devices to be controlled by their own DNS server so they can push out whatever it is they want. But let's go ahead and type in www.blue.com dot, and we're going to get the 192.168. I believe we are, so let's go ahead and do that. And we do. So basically what we're doing is we're intercepting the traffic from those devices and forcing them through our resolvers. And this will allow us to basically control all that stuff, so that way we can ensure that all of our data is encrypted. Okay, so let's do that again. Let's pick a different. So because I chose blue.com, we actually defined it, but let's go ahead and type in red.com. Okay, and if you look right there, see, it's all good. It actually is reaching out to the internet. It's just being forced through here, so we no longer have those DNS, the ones over 53, allowed through there. Let's see if we can find my old query on there. I think it was on there. Yeah, so it doesn't really matter. We'll take off the grep altogether, and we'll run the same query. Okay, so this time we'll put yahoo.com as one. Oh, I gotta put the dot at the end. Feature. But if you notice here, nothing is over 53. So we've completely stopped unencrypted DNS from leaving the network. Now that doesn't mean it can't run over a different port. It just means the normal ports that provide those services that you may ratchet down, you know that they're not going to just willy-nilly go out on the internet and resolve somewhere else. If you're being attacked, if you will, this will make sure that your network gets what you authorize it to see and not what somebody else does. Alright, so to wrap this thing up, we created a visual build diagram of our demo infrastructure. We installed and configured tools that enabled us to perform testing. We set up and configured an Ubuntu Linux box that routed traffic from our pFSense firewall to the internet. We performed real-time packet captures before we enabled DNS with TLS. We enabled DNS with TLS within pFSense. We performed some real-time packet captures after enabling DNS with TLS. Configured internet-only DNS records for our last objective, which was to force all LAN-based DNS through pFSense using a network address translation. I hope you enjoyed our video and have a great day. don't forget to check out our YouTube channel and website at www.vmnerd.com for more tech tips.